welcome back to another new video. In this part, I'll be discussing about the laboratory preparation of hydrogen gas. I have tried to cover the raw materials used, the process in which it is collected, the observation, inference, and also some questions related to this part, which is very much important according to the exam perspective. So without further ado, let's get started with the video. Starting with the second part of hydrogen, that is the laboratory preparation of hydrogen. So the reactants used will be granulated zinc, dilute HCl or H2SO4. So zinc over here is granulated, which basically means some portions of zinc containing some other impurity as well. HCl will be diluted. Along with that, we can also replace HCl by H2SO4, ZnCl2 and H2 is formed as the gas over here that will be collected. So this is how the preparation looks like. We have got zinc granules over here and HCl will be passed from the funnel. Then it will be collected by this method. Now we will be doing in brief the method and how we are collecting the gas, the observation, everything. First question comes up is that, first question is that why is granulated zinc preferred over pure zinc? We could have also taken normal zinc. Why granulated zinc? Zinc granule contain impurity like copper, whose catalyzing effect speeds up the rate of the reaction. So we need a faster reaction. We are trying to get or collect hydrogen faster, so the rate of the reaction needs to be increased. Observation is the effervescence of hydrogen evolved when the gas is being obtained or the gas is being formed. See, gas evolved. This is the hydrogen gas. We can see effervescence, which means bubbles of hydrogen is formed. Okay. Now coming to the question answers from this part. In this manner, it will be easier for you to learn also. Why is hydrogen collected by downward displacement water? Now, the collection in this method, which I have not mentioned, I'm writing over here. It is downward displacement of water. You can write it down over here. Also, you can do it with the question. See, downward displacement, you can see very clearly. It is coming down and water is being displaced and we are collecting hydrogen gas. Now, the question is, why is it so? It is collected by downward displacement of water because it is virtually insoluble in water. Something which is insoluble in water will easily be collected because it is not reacting. If it is soluble, they will undergo reaction. That is not happening in this case. It forms an explosive mixture with air and cannot be collected by downward displacement of air. Why are we using water? Why not normal reaction? Normal air is displaced because there will be some explosive reaction with air. Although it is lighter than air, lighter means it will be going up. Air will be denser, it is present, it is going to come down. But it cannot be used because of the explosion. Name few impurity and method of their removal. So there are some impurities which gets collected along with hydrogen gas. Silver nitrate solution is used. So the impurity is this one. Phosphine, arsine, pH3, ASH3. These are the impurities. Then H2S gas. Also SO2, CO2, NO2. These are all the name of the impurity. The ones which I have marked are the impurities which will be obtained along with hydrogen gas. Not always, but yes, if not maintained well, they can be formed. We are taking impure zinc, so they will be present. AgNO3 is the solution which can be used. For that, we have to add it and they will be undergoing ASH3, pH3 will exclusively undergo reaction to form Ag3S, Ag3P and AgNO3, HNO3 will be formed. So they will be removed, good reaction, PbNO3 and H2S, lead nitrate solution to form PbS and HNO3. Caustic potash, which is nothing but potassium hydroxide. Easily salt will be formed, corresponding salts of all of these, and we can remove them. So this is a good question, important question as well. Name the drying agent that is used to dry the gas. Now see, when you're doing a laboratory method, we basically need something which is pure. We have to increase the purity of the reaction. For that, we have to collect it well, we have to remove the impurity, we have to use a drying agent also. It's not a normal reaction we are carrying out and it's done. So the drying agent over here, CaCl2, KOH, P2O5. Selectively, drying agents are chosen, or else it is not going to be clean or not well dried. Dried and then collected over mercury because mercury has no reaction with it. After drying, you have to collect it. That is done over mercury because no reaction. Now, another type of question. Why is concentrated sulfuric acid not used to dry hydrogen gas? Why are we preferring dilute version? Dilute HCl, dilute H2SO4. Why dilute H2SO4 preferred? Because although H2SO4 is a good drying agent, but it is not used to dry hydrogen gas because of the reaction which it will carry out, as it is going to form H2 and SO2. Hydrogen, where is hydrogen? No hydrogen because it is getting oxidized. Okay, Not possible. Why is nitric acid not preferred? Another good acid we know is HNO3. It's not used. Same problem. HNO3 is going to convert H2 to H2O. And NO gas is released along with that. So it's a powerful oxidizing agent, and oxygen formed is going to decompose the oxidized and oxidize the hydrogen to give water. Not possible. The last question is, name two metals which react with dilute HNO3 to liberate hydrogen gas, Mg and Mn, with very dilute nitric acid. Yes, it is possible to form hydrogen, but we have to use dilute nitric acid, like almost 1% nitric acid, and this question comes in icse board, class 10 board exam as well. So this is a very important question. Magnesium and manganese are only two metals which will undergo this reaction. Nobody else. Okay.
Okay, that is it for this video. I have completed almost the whole part of laboratory preparation of hydrogen gas. Now I'll be moving towards the industrial preparation of hydrogen gas. So if you like this video, please hit the like button and share as much as possible. Thank you.